Alright, so we want to talk about polynomial division here. And the good news is that, again, one of those things that we're really not learning much new. We're borrowing some old information. I'm going to start with dividing a monomial by a monomial. And I'm going to do this using the same method that I would have done or that I teach in the Developmental Math 1 course. So I'm just going to do prime factorization. So 6 is 2 times 3, and then x to the 4th, of course, is x times x times x times x. And then the denominator is 3, that's already prime, and then there are 3 x's, x times x times x times, oops, I'm done, 3 x's. So again, you know, the next thing that we do when we're looking at this is we cross out anything that's the same top and bottom. And then we just multiply back whatever is left. And that's a pretty basic division problem. So let's do one more. It's a little bit more complicated, but not that much. And I'm going to use the same sort of method where I do 2 times 1 times, and then I've got 6 x's, 3, 4, 5, 6, and 4 y's all over 5 with 3 x's and 3 y's. And then again, we cross out the things that are the same top and bottom. And multiply back what's left. So the 2 stays in the numerator times x times y, and the denominator is just the 5. So, you know, this is a long way to do it. Now, we can certainly do this using the exponent laws also. So let's do this bottom one using the exponent laws. Get the red back. And that means that we're going to look at this and this. So we have the 2 over 5, and then we have x, 6 minus 3, y, 4 minus 3. So we have 2 over 5. X 6 minus 3 is x to the 6th, excuse me, x to the 3rd, and then y to the 1st, which is the same as saying 2x cubed y all over 5. So you'll see, oops, forgot my cube up here. You'll see we get the exact same answer. Of course, this one is using the exponent properties, exponent laws, considerably faster. Okay, to continue on, I want to take a little bit of a step back to a regular plain old fraction and think about what the rule is, and that is when we're adding, if we have a common denominator, we just add those numerators and keep the denominator. Now what's interesting about this is this goes both ways. We're used to going this way, but we can also go backwards. This is handy because we can take the fraction and also break it apart. We want to remember this because that is actually what we do when we start looking at these. So we're going to take our fraction, and instead of going this way and trying to add these numerators, these terms in the numerator together, which we can't because they're not like terms, we're going to separate it apart and pull it apart like this. So we're going to do 2x, the first term, over the denominator, and then we're going to keep this, the plus, and the second term, again, over the denominator. And what you should notice is we're back to 2 little monomial division problems, which are hopefully basic if you remember how to do them. And again, we're just going to do, you know, x to the 5th divided by x third, which is x squared. And then we have 5 over 3. We have x to the 6th divided by x to the 3rd, which is x to the 3rd, and we're done. So that's really all there is to monomial division. We just separate it apart, and if you take this step, it's really hard to get any of these wrong. Okay, so this works the same way no matter what the terms look like. So again, we're just going to break it apart. The first term in the numerator over the denominator, the second term in the numerator over the denominator, and then we simplify it out. X to the 6th minus 1 is x to the 5th. Y to the 3 minus 1 is y squared, plus x to the 5 minus 1 is 4, y to the 4 minus 1 is 3, and you're done. And that's literally all there is to. Just a little messy, but let's go ahead and keep working on these. And I just want to show you a few different things that can happen, and this is another thing that can happen. Again, I'm going to immediately, as soon as you see that you've got multiple terms in the numerator, you separate it out. So m cubed over m, I'm going to go ahead and put the 1 there just so we remind ourselves. M squared over m, again to the 1, minus 4 over m. And now we're going to start simplifying that thing. So we start this, we've got m cubed divided by m to the 1st, so we subtract those exponents. The 3, again with the variable, so 2 minus 1 is 1. And now we've got 4 over m, and this is where we have to sort of be paying attention, and we see that we can't do anything to simplify that, so we leave it alone. And if you think about it in terms of, let's say you had, 45 divided by 12, and 12 goes into 45 evenly 3 times. You multiply it back, and then you subtract, and you get 9. 12 doesn't go into 9 evenly, so you've got a remainder. Well, the same thing happens here. This is our remainder. It doesn't go in evenly, but we do have a remainder, so that's why that answer looks a little bit different. Okay, so we're going to do the same thing. Here's another little problem, and give yourself a pause, give yourself a chance to do it real quick before I start. But again, as soon as you see that you've got this monomial in the denominator, that's really your cue that all you really have to do is separate it out. So numerator, first term, 15t cubed, all over 3t. Second term in the numerator, all over 3t. And the third term in the numerator, again, all over 3t. So now all we're going to do is simplify that. So that's simplified to 5. 3 minus 1 is 2. That simplifies to 8. 2 minus 1 is 1. That simplifies to 2. T over t is 1, so that's gone. And that's all there is to it.